who missed because of any reason, you can see it later. So with this, I will start with the portion which we have left. So you people did that sorting of the questions, and you did, and we got this validity calculation of validity index also on that, and that we will show you, because I think one of the participants yesterday asked regarding the content validity, how we can check for the content validity. So there is an index known as the content validity index, and that we calculate based on the inter-rater responses, and that we'll see how to do that. So let's start the session. So I'm sharing my screen, and we'll start with the session which we left, that was the reliability. So first we'll discuss about the reliability, and then we'll see about the content validity, and then we'll go to the breakout room. So reliability, as we discussed yesterday, please see this picture and comment.
Oh, watch this one go. It's nearly in our box. Oh.
Dhoni this time. My goodness.
Here comes Kohli. No, it's not. It's the skipper. It's done. Oh, my word.
Oh, and he launches the big bang.
So what is your reflection on this video clip? So can you say that this shot is a very reliable to be a sixer? The way all these shots were made, repeated sixes, yes? Any other participants? Ria is also saying the same thing. So we can say, so it is easy to measure reliability if we are seeing something like this. Now see this question. There is a person whose actual weight is 60 kg. So he just weighed himself on a weighing scale, and the first reading was 61 kg, and the second reading was 60 kg. The third reading was 59 kg, and the fourth reading was 60 kg. So what is your interpretation about this weighing scale in context with the reliability and validity? So validity, before we actually go, validity is basically, it is what we truly want to measure. So in this case, the instrument will be valid if it is measuring the correct weight of the person. So approximately to this original value, Pragya is writing, Poonam is writing reliable, reliable and valid, reliable. So because the range is very narrow, because we don't say that, it should measure exactly the same thing. There is a variation. So in this case, we can say that this scale is valid as well as reliable, because there is a very narrow range. It is ranging from 60 plus minus 1 kg, and that is generally that error. If you are taking that error as a permissible error, in that case, it is a valid and a reliable instrument. Now in this case, the person's actual weight is 60 kg. The first reading, it gave 51 kg. The second reading gave 50 kg. Third reading 50 kg. And fourth reading 59 kg. In this case, we can say that this scale is not valid, but it is a reliable scale, because every time it is giving the value with plus minus 1 range, but the actual weight is very high as compared to the weight which this weighing scale is showing. So we can say that this scale is only reliable, this scale is not valid. So in case of a weighing machine, or in case of a BP instrument, or in case where we are measuring something like biological parameter, it is easy to check for reliability, because you can take another sample, you can ask the person again to stand on the scale, or you can measure something repeatedly. But how to check for reliability in a scale which you have designed or which you are using to measure a construct? How to check for that? So this is known as the test retest reliability. That means you are doing repeated test, and the reliability of that instrument or that scale is, it is, the value is coming very nearly every time, nearly the same value. But this test retest reliability is difficult to check with the scale, and because you cannot go to the same person. Like if you have administered, if you have asked, in the yesterday example, if you are measuring the statistical anxiety of a postgraduate student, once you have given this scale to that student, you against the next very day, or after 1 or 2 day, 3 day, 4 day, you cannot give the same scale to check whether the responses what he is giving is reliable or not. So that is not the way. We cannot give him the same tool to check for the reliability. Then how do we check for the reliability? So for that, what we do, that instead of measuring, because we are measuring a construct, so what we do, that we devise more than one item to answer the same construct. So in this case, what we'll do, we will ask the construct in different ways, and if the responses are consistent, like if I want to measure the ethics of a medical student, then I may have more than one question related to ethics. Like I may ask, like, do you take consent before, or a consent should be taken before physical examination of a patient? So do you highly disagree to agree? Or you should explain the medication, or you should explain the condition to the person. Or if you're examining a female patient, you should have a chaperone along with you. So are you highly disagree with this statement or highly agree? So for measuring ethics, I am asking more than one question, maybe 4, 5, 6 items to measure the ethics in the medical students. So that way, if you devise more than one item to ask for a construct, then we can say that there is a consistency, because if the person is answering on the same scale, like if all is a positively frame, and if the person is saying like highly agree or agree, maybe there can be a range. If it is a 5-point scale, every time the person may not say, or all the people will not say that it is 5 and 5 only. There will be a person who can say agree, and there will be a person who can say highly agree. So both these highly agree and agree are the same spectrum of answer. At least he is not saying that I disagree. So that opposite pole answer is not there. So if the responses are coming like this, so what you do, you devise your items in such a way that for asking for measuring a single construct, you have more than one items to confirm that. And that's the way we say that the item or the scale has the consistency, or the person has the consistency. And this internal consistency is measured statistically. So we have understood yesterday regarding this anxiety, how do we do that? So if I ask this question, like over last 2 weeks, were you anxious and depressed? So you may answer like yes or no, but I'm asking two things here, anxious and depressed. And we discussed that we should not be asking two conditions in the same statement. So maybe like if I just ask like feeling nervousness or anxious, or if I can have these two responses as a separate scale, as a separate item, that would be better. So I have got like not at all, several days, more than half of the days, like in the past 2 weeks, and nearly every day. So I have got 4 questions or the 4 items to measure this anxiety. The first is feeling nervousness, anxious, or on the edge, not being able to stop or control worrying, feeling down, depressed, or hopeless, and little interest in or pleasure in doing things. So if you see this, and these are the scales, like 0 is not at all, 1 is several days, 2 is more than half days, and 3 is the nearly half day. And like if you have given this question to a person, so these were the responses. So this R1, R2, R3 is the respondent, and these are the items like item 1, 2, 3, and 4, which you have seen here. So this is the items of PHQ 4, that is the patient health questionnaire 4. Now seeing this, can you say a comment about the reliability? Like which respondent, number of respondent is not giving the consistent response? Yes. You can type in the chat box. Like what about R1? Is this person is giving consistent? So R2, Pratibha is writing R2, Haripriya is writing R2. R2, why? Because in item 2 and 3, he is saying 3, but in item 4, he is saying 1. Whereas, I will again show you this slide. This is not at all. So a less score is favorable here. And if person says like 3 or 2, that means the person is depressed or anxious. Okay. So less score is favorable here. So, and all the questions are in the same direction, like all the questions in the scale, the score will be rated similarly. So R6 is also R6. So let me check with the R6. R6, yes, very right, because R6 you can see that for item he's saying 3, for item 2 he's saying 1, for item 3 again he's saying 3, and for item 4 he's saying 1. So by this you can say that if a person is feeling low or anxious, he will score all these items towards the higher side. Maybe the you can say like the maximum score is 3, so maybe 2 or 3. But if the two contrasts are there, like in this case several days maybe, or not at all, in this case one is saying 0, so this 0 0 is okay, then this is also okay. If you say this maybe this 3 3 3, this is a consistent response, but the opposite of this will be maybe the 1 and 3, or maybe the 0 and 3, because 0 and 3 are not at all and nearly every day. So these two are the extreme spectrum which the person has answered. So that's why we can say that the person is not consistent. So reliability is about the person. Reliability is about the person, and validity is for the scale. So that's why we say that reliability will be different if you administer that scale to a different set of study subjects. Reliability of yours using, if I'm using PHQ 4 or PHQ 9 in my study subjects, and if one of the participants you people are doing in your setup, then the reliability will be different for my study subjects and it will be different for your study subjects, because tool is same but still respondents are different. So now what is the relationship between the number of items and reliability? So if you increase the number of items from 2 to 10, so the reliability increases. So we always say that if you increase the number of items, reliability increases, but it has got a non-linear relationship. You cannot say that it will always go on increasing. There is a steady increase from 11 to 30 items, and after 40 items, we can say that there's a plateau. So if you have got 40 items, that is fair enough. If you increase the number of items, the rate of increase in reliability is not that much as you have seen if you increase it from the 2 to 10. So the rapid increase is seen from 2 to 10. Again, there is a steady increase from 11 to 30, and it gets plateau after 40 items. So now there are some basics of reliability. So this reliability is very important when we want to measure a latent variable. We don't observe it directly, rather we inferred it through the other variable. And it is important to maintain that this indicates the consistency of the survey result. So for any tool which we measure, we should report the reliability, and it is measured by the Cronbach alpha, and we commonly use this for the Likert type of scale questions which we have discussed yesterday. So basically we observe something and there is a measurement error associated with it. So this observed value is equal to the true value plus measurement error. So if you reduce the measurement error, if it is nearly equal to 0, then the observed value will be equal to the true value. So for this we do the content sampling, and this is we evaluate by the internal consistency. There is some retest reliability also. You can change the respondents also. And then there is something known as the inter-rater reliability, which we measure because we give the tools like in case of that is the kappa statistics. We do another type of reliability that is also there. In this case, we will do about the internal consistency reliability. So this measures the extent to which the questionnaire items are interrelated, and it shows that there is a consistency in the answering of the respondent. That means we are consistent in the measurement of the same construct or concept. It is estimated using the coefficient alpha, which is also called as the Cronbach's alpha. The value of Cronbach alpha ranges from 0 to 1. And if the value of Cronbach alpha is 0, we say that there is no internal consistency. And if the value of Cronbach alpha is 1, we say there is a perfect internal consistency. So at least there should be Cronbach alpha of 0.7 to indicate that there is a adequate internal consistency. So this Cronbach alpha measures the internal consistency. Its value ranges from 0 to 1, and at least 0.7 value should be there to call it as an adequate consistency. So the basic requirement of Cronbach alpha should be that it should be a continuous variable. And we have discussed yesterday that you treat these scale Likert type of responses as continuous variable, but you can do it for the two responses also. So now there is something known as the unidimensional scale and multidimensional scale. We have discussed this concept yesterday also, where we have seen that GHQ 12, which was a single dimension. And then we have seen the WHO quality of life, which was of multi-dimension. So one thing is to remember that this Cronbach alpha, you have to measure it for every dimension. If the scale is of multi-dimension, you cannot have single Cronbach alpha. So the number of Cronbach alpha which you will report, that will be using the each dimension. So in this case, the variables, they are labeled as item. Now each item is grouped together to form a scale. So like when you are using a tool PHQ-9 to measure the depression, it measures only one dimension. But when you measure this depression using the DAS-21, it has got multi-dimension. So for multi-dimension, you will have more than one Cronbach alpha. The number of Cronbach alpha will be equal to the number of dimension in the scale. And that's why you will do more than one reliability analysis in the multidimensional scale. And it is usually done when the questionnaire has got multiple scale. The second thing is when the questionnaire contains single scale, then we call it as a single dimensional or a unidimensional scale. In that case, you will use only one Cronbach alpha. That means you will perform one reliability analysis. So now what are the properties of this Cronbach alpha? So this Cronbach alpha is the function of length of questionnaire. If you increase the length of questionnaire, if there are many items, then the Cronbach alpha will be definitely high. So this is one way. If you have got more items in your questionnaire, the reliability of your tool will be very high. And we have seen that it increases with the increase in the number of items. There is a rapid increase up till 10. Then there is a steady increase up till 30, and then there is a after 40 it gets plateau. That means increase is not that much. And again it will increase with the variability of each item. How variable each item is, this kappa or this Cronbach alpha, this increases. And again, if you increase again, you will find scale which has got 70, 80 items. So then the value of Cronbach alpha will be very high. So this is again very high alpha. If in your scale, you are getting a very high alpha value, Cronbach alpha, that means it suggests that there are some items which are redundant. That means you may need to reduce the number of items to get it nearly like 0.85 or 0.8, because very high Cronbach alpha, that is 0.9, more than 0.9, it says that some of the items are redundant and you may reduce the number of items just to reduce the respondent overload. Because you can imagine if the number of items are very high, then it will be very cumbersome and for the respondent to fill those many number of items. So it is a way that you should reduce the number of items if the value of Cronbach alpha is more than 0.9. So this Cronbach alpha, it is a property of response of some specific samples on the respondent. So it never reflects the item reliability. It always reflects the respondent reliability. And we have discussed that it is unique for each sample. So it is not the estimate under all circumstances that we have discussed. And then we can say that it varies from sample to sample. That means it should be estimated each time whenever the questionnaire is administered. Variability, Dr. Shivaji is asking what do we mean by the variability of the item. So variability of item means we say that their inter-item correlation should be between the 0.4 to 0.8. It should not be like if the two items are very much similar, not variable, then they will be highly correlated with each other. That means even if you have, instead of two items, if you ask one item, it is going to sufficient. That means they move together. They are so much variability is less between them. That's how we mean by the variability of the item. So variability of the item should not be so low that the both items are behaving in a very consistent manner and their inter-item correlation is very high. That means even if you remove one item is going to measure that construct. Did you get it, Dr. Shivaji? Okay, thank you. And we are going to discuss that content validity index also, which you asked yesterday, regarding like from the expert, how you can actually calculate that content validity index. So this interpretation we have discussed, like if it is more than 0.9, we say that it is excellent, but again, it suggests that there is some redundancy in your item. This good is between 0.8 to 0.9, and then 0.7 to 0.8 is acceptable, and less than 0.7 is not acceptable at all. So Sumit is asking if it varies from sample to sample, then how we can use the same questionnaire from different population. So no, it varies from sample. That's why if you want to use a scale for your own population, that's why all these validation studies are needed. You report the reliability statistics, that is the Cronbach alpha, and then you do the PCA, that is the principal component analysis, and the confirmatory factor analysis also before you actually start applying that scale. So if the scale is that study, many studies has been done. Like if you take a WHO QL or maybe Beck's depression scale, there are many scales which has been extensively used in India. Maybe they have they originated from West, but we have done enough testing here in India. In that case, maybe you can skip with that EFA and maybe the PCA. But generally, if you are trying to take a scale which we have not used, or maybe in your population it has not tested, then it is always recommended that you do the principal component and that is the part of the validity study before you use that scale. And at least report the reliability, that is the Cronbach alpha of your respondent. So that's why we should not use the same questionnaire. You are very right that we should not be using the same questionnaire without validating that questionnaire. So this is one standardized Cronbach alpha where it is based on the standardized item where this Jamovi doesn't give this value. So now there is something known as the corrected item total correlation. So what is this concept? That if Pearson correlation, what you do, you take the correlation between that particular item and rest of the items. So if all the items are measuring the same underlying construct, this correlation coefficient should be high. And this Pearson, if this Pearson correlation coefficient, it should be greater, than 0.3, that means we say the same construct. If it is not, if it is less than 0.3, then you can think of removing that particular item from your tool. That's how we see that. And if the correlation coefficient is negative, you will see that that means we have coded that the question is in the reverse coding. So now there is something known as the R square, and this R square is the coefficient of determination, which we take this in the multiple regression also, and it tells you regarding the variance. So that is the variance which we will see here, and this whole exploratory factor analysis, principal component analysis, it is based on the correlation. So to reduce the burden on respondent, we should use the brief version of scale. And how do we do it? So okay. So now there is something known as the mean score of total scale. So what this mean score of total scale says, or it conveys. So basically it conveys, like if there is a 12 items in scale, like this GHQ, General Health Questionnaire 12. There are 12 items, and if you take response on a 5-point Likert scale, where 1 stands for the strongly disagree and 5 stands for strongly agree. So if the mean score of that scale is 4.1, then we can say that it is somewhat majority of the people, they are giving this option of agree. So you have to relate this, like if it is 4.5 or it is 3.5. So you can say there are more than neutral and less than agree. So that is the interpretation of the mean scale score. Now coming to the validity. So validity is about the scale, but the reliability is about the respondent. We have discussed this. That's why this reliability changes with if you change the study subjects. But validity is about the scale. So how we measure the validity? So we'll see that. So reliability, you have seen like what do we mean by scale reliability? And one measure is to represent it with the Cronbach alpha. Now coming to the scale validity. So like you are weighing 30 kg and the weighing machine in the school of this kid, it is also giving the same value. So this machine is giving the valid result. Again, if I am feeling sad inside and the scale score is saying that I am moderately sad, then again, this scale is giving a valid result. So checking validity for any instruments, like maybe BP machine, weighing machine, or any other machine is relatively very easy task because you can repeat the measurement. But in case of validity check of the scale, we have got many mathematical approaches, but we are discussing one of the approaches here. So there are different types of validity. The first is the content validity. So content validity we discussed yesterday. So if we are measuring any construct and the number of items which we have chosen to measure that construct, it should be adequate to measure that content or that particular construct. This is known as the content validity. Now there is something known as the construct validity. So construct validity is, again, it shows that the particular construct, the item which you have devised, it should be measuring the same construct, not any other construct. And then there is a concurrent validity. So in concurrent validity, what you do, you measure your scale with a standard scale which is available, and then based on those two scale score, you take out the sensitivity, specificity, and all those PPV and NPV and likelihood ratios, and that is called the concurrent validity. So now this construct validity, this is of two types. There is a convergent validity and there is a discriminant validity. So we will discuss this when we will do the EFA also. But this convergent validity right now, I'm just telling you very theoretical. We will do it practically also, how to measure it. So convergent validity is like if you imagine a multi-dimensional scale like GHQ, maybe this WHOQL. So in one dimension, the number of items, whichever are there, that will be the measuring the convergence. So we'll see it. So now coming to the content validity. So content validity is degree to which an instrument has an appropriate sample of items for the construct being measured. This is known as the content validity. So content validity is done in two phases. It is first done by the researcher. So researcher, yesterday we discussed regarding the theoretical conceptualization and operational conceptualization of a construct. Remember, we discussed that we will get the definition of that construct from theory, and we will operationalize it, and then we will devise the item. So it is done by the researcher, by the theoretical and operational definition, and then it is done by the evaluator. So there you can get it done through the expert assessment for the relevance of each item, and that you can do it when you are doing a validation studies. In case of this content, so we discussed about that expert researcher yesterday. So today we will discuss how to do it objectively. If you ask two evaluator, at least two experts will be needed. So what you do, you give those items and then you interpret the evaluator assessment result. So they give rating, and on the basis of that, you measure their agreement. So like you average their rating of that item relevance using a pre-established criteria. You can also do a multi-rater agreement using kappa statistics. So we are not telling you the kappa statistics. We are just telling you in Excel sheet how you can do that. And then you can measure the average congruency percentage. This is one way, but we are not going into the detail. We recommend this calculation of maybe the content validity index. So either you can do that multi-rater agreement using kappa statistics, or you can do the content validity index. So this content validity index, it is most widely used to measure this content validity. So it is calculated at two levels. There is a content validity index of individual item. That means if you are doing a content validity study of a GHQ 12, then you will have the CVI, that is the content validity index of each item, and then you will have a content validity of overall scale. So for this, although in the previous slide we have seen that minimum of 2 experts are needed, but again they say that 3 experts would be better. But range, you can say ranging from 2 to 10 expert or 3 to 10 experts. If you have got more number of experts, this will be very good. So now expert shall rate all the item on the following Likert point. If the item is not relevant to measure the construct, they can give 1 point. If it is somewhat relevant, they'll give 2 points. If it is quite relevant, then it will be a 3 point they'll give. And if it is a highly relevant, they'll give 4 points. So depending on the degree of relevancy which they feel, they will give the item ranging from 1 to 4 points. And then an item is considered valid if its item-wise content validity index is more than 0.8, or overall scale content validity index is more than 0.8. Am I making sense to you? Are you people getting what I am talking? I am talking a theoretical concept now, but we'll see it how to do it practically. So are you people with me up till this point, or any explanation is needed? Can you show me the chat box? So no messages in the chat box. So Dr. Poonam is writing yes. Okay. So I'm taking your yes as a proxy yes for everyone. Okay. Thank you. So that we'll see how to do the calculate the content validity. Now coming to the construct validity. Now what is this construct validity? So we have discussed that there are 2 types of construct validity. There is a convergent validity and there is a discriminant validity. So the extent to which the scale accurately measure what it is supposed to measure, that is known as the construct validity, as the name suggests. So now, like if you can recall the yesterday exercise, there like if there were three dimensions like worth of statistics, interpretation anxiety, test and class anxiety, and all these questions were related to those dimension. So this they are measuring those construct or not. So this will be the one construct, this will be the one construct, and this will be another. So what we say that if you talk about the convergent this thing convergent validity, then the correlation between the q1, q2 and q3, it should be high because they are measuring the same construct. But the correlation between the worth of statistics and interpretation anxiety and test and class anxiety, or between the worth of statistics and test and class anxiety, that means in between factor, this should be low. Otherwise, if it is not low, then everything should be, it should be a one factor. It should not be broken into three factor. But if it has been broken into three factor, that means the inter-factor correlation should be small and the cutoff is 0.3. And this we are talking in terms of a multi-dimensional scale. If the scale is single dimension, then you only measure the convergent validity. That means the inter-item correlation should be more than 0.8. That we'll see. So are you guys clear regarding this convergent and discriminant validity? So this is known as the discriminant validity, in between factor, and the within factor, that is known as the convergent validity. So we have discussed content validity, we have discussed construct validity. In construct validity, yes?
Ma'am, please repeat the last one. Convergent and discriminant validity.
Okay. So convergent, Dr. Shivaji is also writing here. So 0.8 or we can say 0.7. There is a different school of thought, like we have seen different references, and maybe they say that it should be like many people say 0.4 to 0.8. Some people they say 0.5 to 0.8, but generally we take it as 0.7. So this inter-item correlation for convergent validity should be more than 0.7, and inter-factor correlation should be less than 0.3. Yes, that is correct. What is this? Because if you are dividing this whole construct into dimensions. So yesterday we have seen the statistical anxiety rating scale, and there were it was a multiple dimension. We'll see when we'll do the factor analysis. So there one domain was worth of statistics, and another domain was interpretation anxiety, and there was another domain which was the test and class anxiety. So these were the questions. So the correlation between the Q1, Q2 and Q3, it should be more than 0.7, and the correlation between these two factors, it should be less than 0.3. So that we call that. So if it is less than 0.3, we say that there is a discriminant validity. That means these two factors are different, and because these three questions are measuring the same dimension, that means there should be high correlation between these three. Is it clear to all of you? So Sumit is writing, if inter-factor correlation is high, then what does it suggest? Then it suggests that you should not have those many dimensions. You merge everything, and everything is measuring the same dimension. So the scale should be unidimensional. It should not be multidimensional. So yes, convergent applies to the item within a factor, and discriminant applies to factor. Yes, very right. You have nicely summarized, Dr. Shibaji. That's the perfect statement. So should we move ahead? So now there's another term. I'll explain that face validity also. Although we don't use much that in our case, but still that definition we'll see. So now there's something known as the concurrent validity. Now, what is this concurrent validity? So now maybe there is another scale, which I think hypothetically Dr. Shamshad has named it as Pragya's happiness scale, which is a new scale. And there's already existing scale, which is the Oxford happiness scale. So this, like if you are taking this Oxford happiness scale as a standard tool, and you have devised a new tool, maybe any name you can keep, So you will administer the both tool to the same individual and then you compare the result. And then you can do all those sensitivity and specificity calculation. You may use the cutoff points using the ROC analysis. You may see the area under the curve to see the discrimination power. So all those analysis you can do, and that is known as the concurrent validity. So we have discussed content validity. In content validity, we discussed the content validity index, which is calculated for each item and which is calculated overall scale. Then we discussed the construct validity. In construct validity, we have seen there is a convergent validity and there is a discriminant validity. And Dr. Shibaji has summarized that the convergent validity is for the items in a factor and the discriminant validity is between the factor. And then third is the concurrent validity. So this was regarding the validity. So now we'll go to the data set. So we'll see where is the Excel sheet. Yes, so this is the content validity Excel sheet. So I'll first show this, then I'll show you the this how to calculate the reliability analysis also. So you can see here we have taken this response for these number of items are 10. Okay, and 22 people have responded. So you can see Angeline, Arup, Ashok, Aswati. These were the people who were responded. And now we are calculating, although we are taking the 22 people, although we have said that there can be a range from 3 to 10. So that we can do. And then I will answer to your question, Sumit. First, let me show this. So this how you can do. In this, you have to specify a criteria. So first I am calculating the item wise this convergent validity index. So it will be like you have to give a condition count if. So I will give a condition count if, and I am giving it a criteria that I have to see how many of you have responded in a similar fashion. Like everyone has said 3 or 4, because if you see the scale, 3 and 4 says that, you know, highly relevant, and 0 said not relevant and not at all. So for that, you say that I will calculate 3 and 4. Whosoever has answered 3 and 4, I'll calculate the number of respondents who have given the score of 3 and 4 or more than 3. So I will take the number of respondents. So for that, I'll specify a criteria. So I'll select this, drag this, and then put a comma. And then you have to put it in inverted commas if you want to give any criteria. And then I'm writing more than equal to 3. So if anybody has given it more than equal to 3, then I'll take it as a positive response. Again, inverted comma and bracket close, and then press enter. So that this 20 gives you, like 20 people have given this item a score of 3 or 4. So same you can drag for all the other variables. So this formula will be replicated. So you can see this is the total number of agreement. So you can see it's 20, 20, 22, 21, and 15. So this item is having less. Now how to calculate the item wise content validity index? For that, you divide it by the number of respondent. So what I'll do is equal to take this number and divide it by the 22 and then press enter. So it is 0.9. So again, you drag this and you can see here. So for every item, there are items where for this, it is 0.3, 0.2, 0.5. So you have to take all the items. The convergent validity is more than 0.8. So this item number 7, this is again 0.9, this is 1, this is 0.9. So this is how you report your convergent validity for item wise. Now you calculate the overall scale convergent validity. And for that, what you do, you can take the overall average. So average of this. So what you do is equal to, and then select this average. and then take all these value and press enter. So this gives you the average. So average is 0.72. That means it should be more than 0.8. So the convergent validity of scale is less, whereas the convergent validity of few items, and that is because the few items, they have got very less convergent validity. Sorry, this content validity. I'm sorry, I'm using this convergent validity. The content validity is less. So you can see this overall, it is less because there were few items where the content validity is less. Okay, that's why this total, you can say the scale content validity is less. So this was regarding the content validity. Now coming to the reliability, we'll see it on our data. So this is one data. I'll just move these all questions back to the window. So I think those of you, all of you, have you seen the interface of Jamovi, how to import data, etc.? Should I be telling that also, or should? Okay, so before I move, kindly tell. Okay, so Sumit is asking how to find due to which item we get high inter-factor correlation. So the correlation between those two, that you may see that in the inter-rest item plus there in the reliability, there is a column where you see the this correlation between that particular item and the rest of the item. And with that, you can see, we will discuss that also. So, okay, then if that is the case, then I'll close this maybe. So file, I'll have to import. So how you do that? You select, you see this is the Jamovi. All of you will do that in breakout room also, but when you open Jamovi, there is a item, there is an icon, 3 parallel line. You can see there are 3 parallel lines here. So select this and then there's an option of open. So if you click this open, it will lead to, it will ask you to show a path. So you can browse and you can this export the the data, open the data. So this data is on the day 1. So I'll go to the first workshop and maybe day 1. And day 1, you can see that GHQ data, this is coded for reliability. So I have to import this file. So I have imported this file. And now this file, it is open here. So you can see that now this general health questionnaire, we have discussed this general health questionnaire items yesterday also. I'll show you that slide maybe just to, when we're discussing the single and multi-dimension, we discussed this. So this is regarding the measurement of a general health of a person. So let's see. I think I forgot. Yes, it was there. So this was the general. That is there, but how this slide. So this was the GHQ. So can you see this? So these were the questions. Being able to concentrate on what you are doing, felt you are playing a useful part in things, felt capable of making decisions about the things, been able to enjoy your normal day-to-day activities. And these were the positively framed questions, like all days were there are 4 responses: always, frequently, sometimes, and never. And similarly, these 7 to 12 questions, it was like negatively framed, negative questions: lost much sleep over worry, felt constantly under strain, felt you could not overcome your difficulties. So this was like never, sometimes, frequently, and always. So a higher score on this will show you a positive health, and a lower score on this will show you a positive health. So this was the GHQ. So now coming to the data of Jamovi. So this was the GHQ data. So how do we do that? So first I'll uncheck all this. Or I have opened another data also. Yes. So this was the question. I'll just enlarge this. So is the screen visible to all of you? This, you can see in this Jamovi, you will see that if you double click on every variable, you can see you can define these variable like male, female. You can see our previous videos on Jamovi. It is available in our Merit India website and YouTube also. So you can see all those basic feature of Jamovi we have discussed in those videos, and then you can learn about that. But few things I will tell you just how to import the data, because that is needed for this workshop also. Or if you double click this, you can see the type of variable, and these are the levels, how you enter those levels. So I'll just go to the analysis. So there are various options here. You can see this is the variable, this is the option of data, this is the options in analysis. In analysis, you can see there are the option of exploration, which tells you regarding the descriptive and the charts like the scatter plot. Then there are mean tests like independent sample, paired, and one sample. Then there are the options of ANOVA, and then there is an option of regression like correlation, partial correlation, linear regression, and then you have got logistic regression, and then come to frequency where it is the chi-square, goodness of fit, and the McNemer, etc. So now for this workshop, we'll discuss this option of factor, because all our analysis will revolve around this option of factor. So now you click this in this option, you will see that there is a two main heading, scale analysis, and there is a data reduction technique. So in the scale analysis, there is a reliability analysis, and in data reduction technique, there is a principal component analysis, exploratory factor analysis, and confirmatory factor analysis. So today we'll discuss the exploratory factor analysis and principal component analysis, and tomorrow we'll see the confirmatory factor analysis. So I will just click this. So once you have finalized your scale, you have done the reliability analysis. Now the next step is you have done your pilot testing of language, that is the language translation, if it is needed. Now coming to the reliability analysis, click this option of reliability. Now these are the variable, and you have to move these variable to here in this item box. So click this Q1 question, and then press the shift button on your PC, and then select this last question. So it will select all the items and then move these items to this item box. Now you can see there are two classification here. There is an option for this scale statistics. Can you see this? See here on the Jamovi, you can see there is something known as the scale statistics, and there is something known as the item statistics. So are you clear? Scale statistics will tell you the statistics of the overall scale, whereas the item statistics will tell you the item-wise statistics. So we have to check both. So before we go to the item-wise statistics, first check with the scale statistics. So for that, what I'll do, this is the Cronbach alpha. Now in this option in SPSS, this McDonald omega was not there, but in Jamovi, there is an option of McDonald omega. Now, what is the difference between this Cronbach alpha and McDonald omega? These both measure the reliability and statistics, but McDonald omega is considered superior to the Cronbach alpha because there are few assumptions which needs to be met for the Cronbach alpha. And you know that Cronbach alpha you can apply for a single dimension. That means if the scale is multidimensional, you have to apply the Cronbach alpha for each dimension. But if you don't know anything about the dimensionality of the scale and you are not clear how the dimension reduction will be done in your respondent, then this McDonald omega, it works without that assumption also. That's why it is considered superior. Ideal is to click both, and if their value are very much similar to each other, then you can say that the scale is reliable. So in this case, you can see that this is 0.855 and 8.855 for both the value of Cronbach alpha and the McDonald omega. Now you can calculate the overall mean scale also and the standard deviation also. So remember, recall that where we discussed what do we mean by the mean score of overall scale. So that shows you the response. So if the mean score here is 1, so that means they were towards good health. So remember, we discussed that GHQ were 1 and 0. The person who was scoring low was considered of good health. So that shows that the majority of the individual, they were having a good health with a standard deviation of 0.533. Although the aim of this is not to calculate that, we are only doing the reliability, that is the Cronbach alpha. Now coming to this item statistics, it will tell you the Cronbach alpha and McDonald omega if that particular item you remove from the analysis. So click that, and the interface of Jamovi is very dynamic. The moment you click, it will appear, and the moment you uncheck this, you will realize this, it disappears. So if you want to keep these results for your reference, in that case, there is an option of duplicate. So you can select all these results, and then you can right click that, and there is an option of duplicate. So if you click this duplicate, this analysis will be saved. Otherwise, if you uncheck this, this will be lost. So you can see here that item reliability statistics. So it is giving the statistics for each and every item. It is the mean of all the items. This is a standard deviation. This is the item rest correlation. We discussed about the item rest correlation, that that particular item and the overall score of the other item, they should have a correlation of at least 0.3. It should not be less than 0.3. But if you see this, it has got a 0.483, 0.473. Rest also, if you see, everyone is having more than 0.3 except this one. If you see this item, it has got a value of 0.287. Can you appreciate this? So now if you see the Cronbach alpha, each item wise Cronbach alpha, if you drop that particular item, so what you see that if you drop that item, whether your Cronbach alpha value increases, remains same, or decreases. So you can see here the original Cronbach alpha was 0.885. So if you drop any item, the Cronbach alpha is decreasing, not increasing, except for this item number 3, where if you drop this item, this Cronbach alpha, the value is increasing 0.889. Here also you can see the value of McDonald omega is also increasing 0.890. Otherwise, in rest of the item, it is leading to a decrease in the Cronbach alpha. So yes, the decision of removing that particular item, you may decide, you may take a call just to, because the increase is not that much, so you may just report it, and you may like keep this item also. It is up to you. That decision is up to you, whether you want to remove that question or you want to keep that question. So that we test, because that was the question I think Sumit asked, like how to decide which factor to delete. Dr. Sumit, are you, is this was the question which you were asking or something else? You can unmute yourself and answer, or you can, okay. So now is that query solved? Okay, so on the basis, how to grade Cronbach alpha for multidimensional construct. Yes, I may show you. Maybe like if there are two construct, you know how many questions are there in construct. Maybe if, like for example, if I decide that this is of 2 dimension. So maybe I'll again shift this to, so like we will show you with any other personality data also that we'll see. Maybe I have moved this to this. Now I know that from question number 1 to 5, because a dimension questions you know. So from 1 to 5 goes in the A1 dimension. So I will only move these number of questions here in the box, and then I will report the statistics. So you can see that now this has decreased. Maybe this is just a hypothetical example which I'm telling you, but number of questions on that domain you will move here. Similarly, again, now once you have created this, you want to save this result. So you click this, duplicate this, and now you have another this thing. So now you will move this back to here, and from question number 6 to question number 12, you will move there again in this. And then this will be the 0.883 will be of the another dimension. So that's how we do the multi-dimension. That means the number of questions in a particular dimension, you will shift only those questions here in the item. And Dr. Shivaji is asking, will a difference in alpha and omega indicate multidimensionality as well as other than loss of reliability? So if there is a very high difference between these two, then you should report McDonald omega, and maybe the underlying assumptions for the Cronbach alpha, it may not be, your respondent is not taking the dimensions as it has been described in the textbook or in the reference. So in that case, you maybe again you will be redoing it after your factor analysis, because after your factor analysis you have identified that in your scale there will be 5 factor, and these many questions, these items will go in factor 1, these items will go in factor 2, these items will go in factor 3, so that you know. So once you know the dimension in your question, then you can decide about the multidimensionality. Yes, it is there. You are right. So if there is a difference, it will definitely say that the underlying assumption is not met for the Cronbach alpha, right? So I hope anything else to, okay. So I forgot one thing to tell. There is a option known as the correlation heat map. So if you click this correlation heat map, you will see that it will show you the inter-item correlation. So you can see this is the correlation, and this color says you that if I do a reverse scaling of any item, it picks that reverse coding also. Like in this case, if any color is turned red, that means you need to reverse scale that item. Many times we forget. So in Jamovi, there is a very beautiful feature. In SPSS, you need to recode it. So if many of you who have done your analysis in SPSS, you need to go there, you need to recode your variable into a new variable, and you need to reverse scale that item. But in Jamovi, if like any scale, if any value is coming like red, see if I shift this question number 9 here. So you can see there, this will appear red. So it is showing that something is not right. That means these questions should not be in the reverse scale. So that's why I will move again this back to this window. So this reverse scaling, you only need to move this normal scale number, those many questions where you need to do a reverse scaling, just move this question here. You don't need to again repeat it, that reverse coding. And this was the item correlation, that is the inter-item correlation. And you can see the inter-item correlation, all the value of correlation like 0.52, 0.55, 0.53, etc. Now coming to the, Sumit is asking me to explain once again the inter-item. Okay, I'll do that. So maybe I'll again, because for that multi-dimensionality part, I have moved this. So again, I'll move everything here because it's a unidimensional, and I'll move all the items together. Here. So now, first identify this term. There is an term known as item, and there is a term known as rest. So what, okay, Pragya is not understanding reverse scale. Okay, I'll explain you that once again. Item rest correlation means this value 0.483, it gives you the correlation between this question number 1 and the mean score of all other items, like question number 2 to 12. Sum of, like not the mean, sum of. So if you take the sum of correlation of 2 to 12 and the correlation of, and the this value of score, not the sum of score of question number 2 to 12 and the score of question number 1. In the correlation between these two values are known as the item rest correlation. Means correlation between that score of particular item and rest of the score. And then this value, you see that this value should not be more less than 0.3. So in this case, you will see that because if the item is less than 0.3, that means that is not correlating with all other construct, because all other questions are measuring the same or giving the response in the same, but this is not giving the response like the other questions are, we are getting the response. So if the correlation is low, that means it is not measuring that same thing. And if you remove, and then again you have to measure. So you have to report this. Item number 3, it is showing a correlation of 0.287. And like if you remove this item from your question, then your reliability or your Cronbach alpha is increasing. So initial value was 0.885, but now it is 0.889. Similarly, McDonald omega is also increasing. So this is the interpretation of item rest correlation. You have to give this table and you have to explain that in the result. Is this okay, Sumit? Okay, now coming to the reverse scale. So reverse scale, we have seen that there is an option of reverse scale. So many times what we do, we say that the questions should not have the same scale, but you ask a negative question. In this case, like if you come to that PHQ, that GHQ 12, so these scale, lost much sleep over worry. So like if the same scale we have used, like always, frequently, sometimes and never, then these were the negative reverse scale, because the higher value will show a good health, whereas a lower value is showing a good health in this case. So for that, just to, in this case, since this person has reversed the responses, so it is now in the same scaling. But many times you will see that the same response is there, like always, frequently, sometimes and never in all the questions. But some questions are negatively framed. So lower response is desirable. And in that case, you need to negative reverse code that, because if you don't reverse code that, the value will not come and it will show you a negative correlation. Why? Because low score of something and high score of something. So low score is giving a good health and high score is giving a good health. So there will be a negative correlation. So if there are negatively scaled item in your data, then heat map shows that. So that's why that was the thing which I was telling you here. Just a sec. So this we see as a, in this case, it will not be there. But in your case, like if you forgot to reverse scale your item, and if your scale has got a negative questions also, and the measurement of the scale is there on the same type, then you need to reverse scale your item, right? And in that case, you can only shift this and this heat map show you. Okay, we'll show you wherever it will happen, Pragya, then it will become more clear to you. Okay, we have just shown you as a demo that if there is some red color is there in your heat map, that means that particular item is a reverse scaled item and you have forgot to reverse scale it. I mean normal scale it. Okay. So Shivaji is writing, what if alpha reduces too much if the item is removed? Then also it will not, I don't think it will have any other, because this we just see that if the item is this, whether it has, in this case, can I see any other example, 8718? So I don't know why the reduction will cause a reduction in alpha, that is too much of alpha. Because normally what we say that if particular item is dropped, whether that Cronbach alpha is increasing or not. If the reduction is high, that means it's a very important item for that particular, because removing that is reducing the alpha with a very high degree. So yes, so I have to read it with the previous one. What to do with the items that score correlation of more than 0.9? So you can take a call and you can remove the item. So they should be merged with some other item. Yes, but still that If it is getting reduced, that means ki it is a very important item. You are never going to remove that item. It is a very important item because after removal, that alpha is getting reduced. That means it is impacting you. That should not be removed. The other
And the question was if some item has a item rest correlation of 0.9 or more,
okay.
and we see that if that item is dropped, the Cronbach's alpha is also getting reduced by a significant margin. What to do? We can remove that item just because it has a significantly high correlation. What to do in that case?
Okay, so you are saying that the correlation is high, and if you are removing that, then the Cronbach alpha is getting reduced. That's what.
Yes, yes.
Okay, I got it now. Maybe that's why you were saying that read it from the previous. So that's how you guys also need to unmute and talk, because many times it is difficult for me to understand. So now I got your question. So in that case, it's better that you keep that item, because we never want that alpha to be reduced. So even if it is redundant, that is okay. In that case, you should not remove that item.
Okay, thank you.
Okay. And any other question before we move to the breakout room? Any other explanation? Any other question? Concept you want me to repeat, or you want to ask something? Then you can. Otherwise, we'll go to the breakout room. If not, you will be doing. They're not going to do with their data which they have filled. Okay. So there is a PHQ9 file also. You can do it on that, and there is a data which you guys have filled yesterday and asked your friends to fill. But again, you can do. It's up to you. You can do on the PHQ9 also for practice. And then later at home, maybe you can do on that particular data set which we have shared. That how many responses were there? 93. Okay, so Dr. Naveen, will you please open the breakout room, and it is requested from the mentor. Kindly ask from each and every participant, please